Hello and welcome back. We're going to do more with statistics. We're going to go back and look at this data sheet I already have that we've used a few times over. Or we're not necessarily going to use columns B and C this go around. We're going to go back and use column A because of the data that we can pull out of there. Now, one of the things I will do at this point is kind of remind you that when working with data sets in Excel or Google Sheets or numbers, you might want to add in the some analyzing packages that are available. In Excel, you can actually just go to data. You go to your data tab here, and you over here analysis tools, and you can click these two little buttons here and click OK, and then you get these other parts on here. So now you can go do more analysis with your data set. Now, one thing I can do here is I can just click this whole arrow and highlight the entire arrow, and then click on analysis here, and then I have all sorts of different things I can do here to figure out what's going on with the data. All sorts of different interesting things I can ask the system to find for me. Now, one of the things that I want to do in this particular instance is I want descriptive statistics there. Okay, so there are keystrokes for Google Sheets in numbers where you can do and get the same thing. I don't necessarily know those keystrokes, but they shouldn't be terribly difficult to find, especially with Google Sheets, which really does try to mimic Excel to a large degree. You might have to add on the analysis tool or library for Google Sheets if you haven't already done so. And if you need help with figuring that out, I will try to go find or figure out how to do that myself and post a video on that as well. Please just leave those in the comments or for those who are taking my course, send me an email about that. Okay, so I'm just going to click OK. And when I do that, it's going to ask me for my input range. Well, I'm going to ask for starting there, and I'm going to hold down my shift key and just start arrowing down to collect all that data. Now I could have also just picked the entire row, okay? And then it's going to ask me, where do I want to put that? I'm going to click right here, and I'm going to say, put it right here for me, okay? And I can tell it to put it wherever I want. It was going to output it to a whole nother sheet for me, but I'm just going to have it right there so I have it on the same sheet, and I can actually go up here and say, well, put it right here. That way it's at the top of my sheet, okay? And then I click OK, and OK. Well, what did it like? Oh yeah, I didn't tell it what I wanted. So I wanted some confidence intervals and some means and some other stuff like that. Let's see now, does it like that? There we go. Now it liked it. So now it told us what column 1 was. Now if I'd gone in and I'd entered in some information about what column 1 was to begin with, it would actually carry that over for me instead of just saying column 1. Now, I have these, I'm just going to widen that over so we can see all these pieces here, and we will go back and we'll talk about each of these pieces, or some of these pieces at least, a little bit more detail down the road. Now, one of the things I want to point out is here's our mean. Now, in a previous video, I actually talked about how in Excel we can actually have it find the mean, which is right here. All I did was just typed in equals average, and it gave me the average. You can also get the system to find the standard deviation for you. Like if you were to go home and you go to formulas here, you can actually click on more functions and you can actually search all the functions. So if you were looking for one, you could type in, say, standard deviation. Apparently it's not going to let you do that one. But you can type in anything that you needed to find, averages and statistics. There's some other statistical ones there as well. All right. So going back to my chart here, here's the average, 900.882. Most of the time for me, I really do prefer that you go out 3 decimal places. And one of the reasons for that is if you go out 3 places, you're more or less talking about a fairly accurate piece of information. As opposed to only going out 2 places or 1 place. It's an accuracy level. Standard error, 25.74. We'll talk more about that later. 901. In a previous video, we actually created a box and whisker plot, and we found that the median was 901, which means the middle value, which was right here at 2625, since we have 51 pieces of data there, right? We have standard deviation and standard variance. Now, these are the two I actually want to talk about, but I'm going to come back to that in just a second. And then we have the range, meaning the highest, the lowest values, the minimum, the maximum, and the sum, and the number of pieces we have in the data set. So and all those things are interesting. Then we have the confidence level as well, and we'll come back to that one later too. So the standard deviation. Well, and the variance. Now, one of the things we need to do is we need to talk about where these values are coming from and what all they are. So one thing I just want to point out here is I'm going to do equals, and I'm going to do square root, which I'm just going to type in SQRT, and I'm going to grab the number I want it to do, which is just that number right there, which is the variance. Close my parentheses and hit enter, and look at that. That is the exact same number as what it said for the standard deviation. I'm doing this to point out the fact that when we talk about standard deviation, what we're referring to is how the standard deviation is the square root of our variance. Okay, our variance is this number right here, which is 33814.749. So it's 33,000. So what does that mean for the variance to be 33,000 with this data set? What does it mean for the standard deviation to be 183? Well, when you looked at our data, and there's lots of ways that we can look at this data set here, but when we look at our data set, what we're saying is that 183 is one standard deviation. So if we were going above that mean of 901, and we just kind of simplify these values a little bit here. So if we go above that, we're going to say this is equal to 901. Actually, you know what I can do? I can click on that and hit plus my standard deviation like that, and go below that, and I can say this is equal to my median and my mean minus my standard deviation. All right, so this tells us that the majority, I'm going to talk more about this in another video where I dive in directly on standard deviation. This is kind of a how-to more than anything else right here. We have one standard deviation above and below the mean. So most of our data is actually in this realm right here between 1,084 and 716. Okay, so this was data talking about the number of nurses per 100,000 people per state. So most states have between 1,084 and 716 or 717 nurses per 100,000 people. Now, what does that mean? Well, what it means is that as the further out you go from that mean of 900, the fewer and the fewer groups of people that are going to be in there. Now, so if we're thinking about this being a normal curve, we're getting very small values as we move further and further away from that mean. It doesn't mean they don't exist. It's just there's fewer and fewer of them. In the United States, of course, we have a limited number. There's a finite number of states, so we can't just go on infinitely. Now, if you look over here, we're talking about, here's 717 right here. Okay, and I'm just going to put a little mark here. I'm going to highlight this with like a yellow here so we can keep track of it. And the other value is 1,084, which is, right, well, it's not really on that chart, is it? So what we can do is take the closest value, which is, say, 106 there. And again, I'm just going to mark it like that. Now we're going from 10 to 38. And if we think about that being inclusive there, that is going to be it's going to be one more than the number if we just subtract them. If we're including the fence posts, so to speak, we're counting the number of fence posts, not counting the number of jumps. And there are 29 states that fall into that realm there. Meaning, with one standard deviation in either direction, we are accounting for 29 of the states, 29 of the 51 states in the United States, or 50 states in the 51 pieces of data in this set, right? Because we're including District of Columbia in this count, right? So when we look at this, we have 901 right here in the middle, and we go up and we go down from there. We're going up so many, we're going down so many. And when we think about it being right there at 901, let's count how many are above that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Count below that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's not the same thing as the box and whisker plot. The box and whisker plot, what it actually does is it actually splits the data up into based on the number of pieces in each set. So 25%, 25%, 25%. So breaks it down into quarters of data. That's not what we're doing here. This is a little different than that. We got 15 pieces of data above that and 12 pieces of data below that. They're in one standard deviation, which is more than 50% of our data. So, and keep in mind, it's not the average in this particular instance is about in the middle. That just kind of happened with this data set. But we have more than half the data in this realm. We have actually the majority of the data in this realm, not a super majority by any means, but we have more than 50% of it. So what does that mean? It means that the data here is fairly, especially directly below this, is a really tight-knit group of data here. You're going from 901 to 717. You're not even talking a span about 200 yet. You go from 901 to actually, I guess that's a span of 183, right? Well, what happens when you go another 183 out the other direction? Well, let's take this value here, and let's do minus our standard deviation again. That takes us to 533, which is all the data directly above that. Let's go the other direction. Let's go from this value, and let's add in that standard deviation. So that'd be 2 standard deviations. So now we're talking about including this one completely. I'm going to change it a little, give that a different color, call that a blue there. So that's 2 standard deviations, and then my other value there is 1268, which is the closest to that is about 1260, it looks like. We'll cover that in. So there's actually, this would be almost all of our data at this point, except for 2 data pieces. So there are 2 data pieces here that are more than 2 standard deviations outside of our mean. What that means is these 2 pieces of data, these 2 states, I think one of them is the District of Columbia, if I remember correctly, they are well outside of the normal expected outcomes of the number of nurses per state. That tells us a lot of information. Like, this isn't what's normal. This is really kind of exceptional. This is you might even say, well, this is an outlier. If we go one more standard deviation out, okay, so we're going to do this equals plus one more standard deviation. All right, there's my standard deviation. I get that, and I get 1452. Well, this is not even within 2 standards. So this is 1 standard deviation, 2 standard deviations, 3 standard deviations. This is not even within 3 standard deviations. So this 1483 here, this last value here, is actually 4 standard deviations away from the mean, which means it's well outside what we would typically find. It's not something that is going to be very common. And if we were to talk about this from a bigger perspective, we would expect any given value to be in this realm here between 717 and 1006. That is a fairly normal range. Now we can start asking other questions about who has the best healthcare, where are people the healthiest, and if the people are healthiest in this realm right here, well, most people should be in that realm. If the healthiest people are right here, where we have 1483. Maybe we should make it a goal to have all states in that realm. So maybe 4 standard deviations beyond what the current average is what we should be aiming for. I'm not saying saying that is definitely what we should be going after at this point, but that is a possibility of things we could be working on. So this is just an analysis that allows us to lead to other questions and be able to ask additional questions to get additional answers so we know more about what is going on within a system. This is just the beginning of this analysis process. And we'll talk more about what the standard deviation means and what we expect to normally happen with those pieces as we start to talk about them. Okay, also notice here we also have mode of 814. Not really sure what that means in this context, other than the fact that we have it appears twice, but so does 901. It also appears twice. So, and it's not listed there either. So the system just kind of gave us the first one it came across as opposed to all of them. The sum here is actually useful, as is the count and some of these other values that are here. And I'll show you how we can use some of those other values down the road. Thank you, and have a good day, and take care.